Good morning everyone. First of all, I introduce myself. My name is Dharani son of Murugia. My ID number is 01D8023F1094. In this presentation, we have 3 to 17 pages. Each page we have each title. For example, page 3 is Team Roles and Responsibilities. Page 4, Introduction to Differentiation, Technique of. Page 5 is Technique of Differentiation. Page 6 to 8 is Differentiation Rules. And 9 to 12 is Example of Differentiation in Real Life. And 13 to 16 is Question and Solution with Graph. And lastly, the 17 is the summary. Okay, the next is Introduction of Differentiation. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method to finding the derivative of a function. Differentiation in process in math, where we find the instantaneous rate of change in function based on one of its variables. It also allows us to find the rate of x with respect to y. The most common example is rate change of displacement for time, called velocity. Differentiation is widely used in solving problems, especially in engineering, medical, architecture, and many. We have 10 different techniques of differentiation. For example, the first technique is basic rules of differentiation. The second technique is derivative of trigonometry. The third technique is logarithm. Fourth technique is exponential function, and fifth technique is second order differentiation, and sixth technique parametric equation, and seventh technique is implicit differentiation. The eighth technique is partial differentiation, and ninth technique is total differentiation, and lastly is application of differentiation, maximum, minimum, and point of inflection.
Hi guys, my name is Sugan son of Ganesan. My metric number is 01D8022F2030. Today I am talking about in engineering mathematics 2 topic is differentiation. In differentiation rules have 7 rules like constant rule, multiple constant rule, power of rule, and sum rule, and product rule, constant rule, and the chain rule. Have 7 rules. Our constant rule is the derivative of any constant function is always 0. The constant multiple rules is multiply derive of the function, like function is constant multiplied by the derivative of the function. And the power of rules is base raised to power being another power. And the sum rule is derived in sum is the sum of derivative. And the product rule says derivative of product of two functions is the first function is times the derivative of the second function plus the second function times derivative of the first function. And the constant rules have is denominator times derivative of the numerator. And the chain rules is find the derivative of function that is composition of other function. And we have for example differentiation in real life question, like find the rate which the height of the water rises in mH in water tank, in force in pouring water in tank of rate 20 m over h. Here I have an answer like example like this: dv over dt with chain rule method. Therefore, the rate at which the height of water rises in the tank is 0.333 m over h. That is answer. And lastly, I have an example question 2, like the rectangle ABCD such as that DC equals 6. Inside DA extended to a point E and the side DC is extended to a point F, so it's a straight line. Determine with full justification the minimum area of the triangle EDF, minimum A equal 48. And the answer we have like this, starting with the diagram, and second step is get an X, and third step is differentiation AWRTX and verify it is a minimum. And that is a example of differentiation rules question.
Hello everyone, my name is Joel Christopher and my metric number is 01DAD23F1082, and today I would like to do the question and solution with graph for our question, which is based on our topic differentiation in chapter 2. So what question that we chose is question A, y equals 4x to the power of 3 minus 2x to the power of 2 minus 5x plus 1. So what we have to do in this question is use the differentiation to find expression for dy dx, find the coordinates of any stationary point on the curve, calculate the stationary points on the graph, determine the nature of any stationary points that found in part 2 and justify the answer, and finally we have to sketch the graph of the curve. So next slide, I would like to explain to you the working. I would like to summarize the working, and yeah, let's go to the next slide. Thank you. So to easily summarize for you this working, I guess you guys can see it by yourself how I did the working, but just to explain to you guys, so firstly we have to find the points of the curve where the tangent line is horizontal. We need to find the derivative of the function and set it equal to 0 since the slope of the horizontal line is 0. So firstly you have to, as usual, differentiate the function with respect to x. Secondly, we have to set the derivative equal to 0 to find the x coordinate where the slope is 0. Next, we have to factor the quadratic equation. We solve for x again. Then we substitute x back into the original function to find the y coordinate. And once we get our x, which is 5/6, we just do our normal calculation, which is to be the next slide. You can see it in the next slide, where x is -1/2 and y is 311/54. So therefore the points on the curve where the tangent line will be horizontal are -1/2 and 21/2 and 5/6 and 311/54. So that is the final answer, and you can see the graph we did on the next slide. And yeah, thank you, that's all. So now for the summary of our presentation. Differentiation is done by applying the techniques of known formulas and rules in finding the derivative of given functions. The process of finding the derivative of a function is called differentiation. The three basic derivatives are differentiating the algebraic function, the trigonometric function, and the exponential function. We use the differentiation formulas to find maximum or minimum values of a function, the velocity and the acceleration of moving objects, and the tangent of a curve as well. The differentiation of a constant is 0 as per the power rule of differentiation. So that's all from our team. Thank you so much for watching our video presentation. I hope you guys enjoyed it. So thank you, goodbye.